So when you've got an AI that needs to understand a document, size is a really big deal. But what happens when that document is hundreds, maybe even thousands of pages long? Today, we're going to dive into the smart techniques used to feed these massive texts to an AI, a process called chunking.
Okay, so picture this. You've got a 500-page legal contract. How in the world do you get an AI to read it? I mean, you can't just upload the whole thing and cross your fingers, right? Large language models, they have a limited attention span, what we call a context window, and just forcing a huge amount of information on them at once, well, it just doesn't work. And if you try, the AI just chokes. It's going to miss key details, lose the big picture that connects all the ideas, and honestly, because you're processing so much data so inefficiently, the costs can absolutely skyrocket. So yeah, we need a much smarter way to do this.
And that, my friends, is where chunking comes in. Now, this isn't just about randomly slicing up a document. It's a real science. The science of strategically splitting documents into smaller, intelligent, and context-aware pieces that an AI can actually digest and understand.
All right, so let's start building our workflow. We'll kick things off with two foundational methods. Think of these as the absolute essentials, the building blocks you really need to know for almost any project. First up, we've got Level 1, Fixed Size Chunking. This is about as straightforward as it gets. You can literally think of it like tearing a set number of pages out of a book. It's a bit of a brute force method, but you'd be surprised how useful it can be in the right spots. So how does it actually work? Well, under the hood, you're often using a tool like a character text splitter. You basically set a chunk size, let's say 384 characters, and the code just cuts. That's it. Then there's this chunk overlap parameter, which is pretty clever. It repeats a little bit of text between the chunks to try and create a bridge, to keep some of the context from getting totally lost.
Okay, so right away you can see the trade-off, can't you? On the one hand, it is so fast and super cheap. We're talking 150 milliseconds to process a document. But the downside? Well, this method doesn't care about your sentences or ideas. It might just slice a key fact right in half, which can totally confuse the AI.
So you might be asking, when would I ever use this? Well, it's perfect for things like high-volume system logs. Think about it. When you've got a flood of simple, time-stamped data coming in, all you care about is speed. Perfect context isn't really the top priority.
All right, time to level up. Next is Level 2, Recursive Chunking. And this one is way, way smarter. Instead of just cutting blindly, it actually tries to understand the document structure first. The magic here is in that separators parameter you see in the code. It's basically a priority list. The algorithm will try to split by paragraphs first. If that chunk is still too big, okay, it'll try splitting by sentences, and so on. It works its way down the list, always trying to respect the natural flow of the document.
And here's the kicker. You get this huge jump in quality, but for a really small increase in cost and effort. You're getting something like 90% of the performance of the really fancy methods, which makes this an incredibly efficient choice.
So this is your go-to for structured stuff, like technical reports or business analyses. For example, if you're analyzing customer churn from company filings, you need to keep those paragraphs together to get the right meaning. This method nails that.
Okay, so we've got our foundations down. Now, let's get into the advanced stuff. This is what you pull out when precision is everything, when you just can't afford to be wrong.
And that brings us to Level 3, Semantic Chunking. We're not just looking at paragraphs and sentences anymore. Nope, this method groups text based on what it actually means. It's smart enough to split the document whenever the topic changes.
I mean, this is a massive leap forward. It uses something called AI embeddings, which are basically like a mathematical fingerprint for meaning. It looks for those fingerprints to find the natural places where one idea ends and another begins. The result? Chunks that are all about one specific topic.
But of course, all that brain power comes at a cost. You're looking at indexing that's 2 to 5 times slower. But the payoff is huge, a 15 to 30% boost in what we call recall. And that just means the AI is way, way better at finding all the right pieces of information for your question.
So where does this shine? It's absolutely perfect for analyzing conversations like transcripts of customer service calls. The AI can literally pinpoint the exact moment a customer goes from talking about a billing problem to a technical issue. And that kind of insight is pure gold.
All right, we're at the final level now. This is the big one, hierarchical chunking. This is the production-grade, heavy-duty solution for those monster documents. The strategy here is just brilliant. It creates multiple layers. So at the bottom, you've got these small, super detailed chunks. But then, those little chunks are linked to parent summaries that give you the bigger picture. This means the AI can zoom way in for a specific detail or zoom way out for a high-level overview. And get this, it can cut the time it takes to find an answer by up to 40%.
So, remember that 500-page legal contract we started with? This is how you tackle it. When you have a document where the AI absolutely has to understand both the tiny details and the overall strategy, this approach is pretty much unbeatable.
Phew! Okay, so we've walked through 4 really powerful methods, each with its own pros and cons. So the big question is, how do you pick the right one? Well, let's let the data do the talking.
This chart here tells a really simple but powerful story. You can see it right there. As you go up the ladder from fixed size to hierarchical, the precision score just keeps climbing. It's a perfect visual of how much accuracy you gain with the smarter techniques. And this table, this is your cheat sheet. It lays everything out all in one place. You've got the level, the precision score, the speed, the cost, and a great use case for each one. This makes it so much easier to match the right strategy to what you actually need to do.
So, after all that, what's the one big takeaway? What's the golden rule? It's this. For probably 80% of what you'll ever do, you should just start with Level 2, recursive chunking. It really hits that sweet spot between performance, cost, and simplicity. It's your workhorse, your reliable default.
Okay, let's wrap this all up. We're going to boil it all down into a simple, actionable playbook for you.
It really is this simple. Number 1, use fixed size when you need maximum speed and you don't care as much about precision. Number 2, use recursive as your default for pretty much most projects. Number 3, bring in semantic when you absolutely need to understand the context and topic shifts. And finally, number 4, use hierarchical for those giant complex documents that need both the details and the big picture.
And that leaves us with one final big question to chew on. As AI models keep getting bigger and better with these massive context windows, are we even going to need to do this anymore? Will chunking just go away? Or will the art of carefully preparing information for an AI always be a critical skill? It's definitely something to think about as this tech keeps racing forward. Thanks for joining me.